These are the frequently asked questions for pre-calculus for section 3.5, day 2. It says, in exercises 25 to 38, solve each equation by the method of your choice. Support your solution by a second method. I'm not going to worry about supporting with a second method. I want to see that you're able to solve these. So, number 35 was the first one that you had asked about, and this one has 1/2 natural log of x plus 3 minus natural log of x equals 0. So one of the things that I thought of right away when I saw this was that if we can get a natural log on both sides of this, then we could just drop the natural log. It'll almost be like thinking of the bases as being the same. It's that one-to-one relationship. So if I put this 1/2 back up here where it belongs as a power and move that natural log of x over by adding it, it'll look like so. And that means the natural logs are no longer a part of the equation. I don't need those to be equal. I need these two pieces to be equal to each other because the natural log of both of those have to be the same. And then what I would do is square both sides. You could either think of that as, a square root on the left-hand side or as a 1/2 power. Either way, we're going to square both sides. And keep in mind that that might introduce extraneous solutions. Because up here we can see that what we're evaluating is supposed to be linear, so we really should only have one solution. So this will give us x plus 3 equals x squared. And if we bring it all over to one side, we see that we now have a quadratic. And we would be hopeful that it is factorable, but that's all that is. It's a hope because it is not factorable. So we'll move the 3 back over to give ourselves a little room to complete the square. So our b value here is -1. We would do -1 divided by 2 squared to get our c value to complete the square. And that is 1/4. Now 3 is the same thing as 12/4, so over here we'll have 13/4. And we now have a perfect square trinomial, so we will factor that as a binomial squared, x minus 1/2 squared. Then we would take the square root of both sides, which of course means we're introducing that plus or minus piece, and do a little simplifying. The square root of 13 is the square root of 13. It's not simplifiable, but the square root of 4 is 2. And then we would add 1/2 to both sides. And still keeping in mind, one of these solutions is going to be extraneous. We punch it in and we get x is approximately 2.3028 with addition, and x is approximately -1.3028 with the subtraction. And we just found our extraneous, and that would be because if we put this back in the original, we would be trying to take the natural log of a negative number, which we cannot do. So, interesting way. Again, not the only way to solve it, and like it said, you certainly could pick different methods for this one. But I think that's probably the easiest way to understand the relationship between those two. Then, number 36, we're doing the same thing. Again, I'm just going to solve this one way rather than make any confusion. And so in 36, when I take a look at the problem, I realize this is not the situation that I was just in with 35. I can't put one on one side and one on the other side. And that's because we don't have a 0 on this side. We now have a 1. So instead, I decide I'm going to go ahead and do some condensing here and see what I get. So the logarithm, common logarithm of x minus 1/2 logarithm of x plus 4 equals 1. So first thing I need to do is get that 1/2 back up as a power where it belongs. And again, that 1/2 power is the same thing as the square root. So I might write it like that at some point so people aren't so ill at ease with it. We have subtraction, which is division. In fact, I'll change that over right now. And then at this point, I do have one logarithm, which means, and it's common logarithm, that I could snail shell, exponentiate this. And that would give me 10 to the first equals x over the square root of x plus 4. And I would probably just treat this as if it were a proportion and say, okay, I have 10 times the square root of x plus 4 equals x. Again, keeping in mind that when I started what I was evaluating was linear, so again, probably going to have an extraneous solution when I get done. I do not want that square root of x plus 4 sitting there, so there's two things I can do. I can square both sides right at this point if I want to. If you're uncomfortable with that, you can divide by the 10, but again, you're going to be squaring and things will be messy. So either way, but we're going to square both sides, and we have to square both the 10 and that quantity of x plus 4, so that will give us 100 times x plus 4. We can go ahead and distribute that and realize we do have a quadratic, so let's get a 0 and take a look at it. And two numbers that multiply to negative 400 and add to negative 100, that is not going to be nice. So I'm going to get my 400 out of the way by adding it to both sides and completing the square. Now our b value is 100. If we take 100, negative 100, and divide it by 2, we get 50. And if we square that, we get 2,500. So we need to add 2,500 to both sides. And that will give us 2,900 equals x minus b over 2 was 50 squared. And then we would take the square root of both sides. And of course, that's our plus or minus piece right there. And now normally, we would want to go ahead and simplify that plus or minus 2,900. And that's because with 2,900, we would have the square root of 100 and the square root of 29. So 10 square roots of 29. But for punching it in, we really didn't even need to do that. We're going to add 50. And for punching it in, it probably would just be best to leave that as the square root of 2,900. But again, you make some points with the greater by simplifying that. So I would probably punch in this piece right here, and the two solutions that we get when you do addition, 103.8516, and when you do subtraction, negative 3.8516, which again, when you go back to the original, you will see that your negative is extraneous. We cannot take the common logarithm of a negative number. Number 38, we are in the same section still. And I look at this and I think, okay, with this one, if I can get log on one side and log on the other side, then I can drop that common logarithm. So what I have to do is I have to condense, and I have to figure out when it is that I can drop these pieces. So I write the problem down, and I realize, okay, I've got addition, that's multiplication, no big deal, I can take care of that. And then I have this 2 out in front, well that was a power. So this is the logarithm of the quantity x minus 2 times the quantity x plus 5 equals the logarithm of 3 squared, which is 9. You're just putting that right back up there. And now I definitely can drop that common logarithm. And I'll do a little FOIL action on my parentheses, move it over, but we pretty much know already what's going to happen here. We don't have two numbers that multiply to 19, and negative 19, and add to 3 in the middle there. And I think I'm going to go ahead and complete the square, even though this will be another fraction one. So we have x squared plus 3x, move that 19 back over to the other side, and then we would have 3 divided by 2 squared, which is 9/4. And 19 is the same thing as 76/4, so 76/4 plus 9/4 gives you 85/4. And over here, we now have a perfect square trinomial, which as binomial squared would be x plus 3/2 squared. Let's take the square root of both sides, and x plus 3/2 equals plus or minus the square root of 85 over 2, and then we would subtract 3/2 from both sides, and consider the 85 and whether or not we have any perfect squares that go into that. But again, we wouldn't necessarily need that to get our answers here. So negative 3/2 plus the square root of 85 over 2 is 3.1098. And then with the subtraction, negative 6.1098. But again, if we go back to the original, we'll see that these terms are linear, which means one answer, and again, the negative is not useful to us. So that's one good method for solving each one of those, and that should be enough.